Let's solve a problem using the normal distribution. Here we are told to assume that a set of test scores is normally distributed with a mean of 80 and a standard deviation of 15. And we're going to use this 68, 95, 99.7 rule to find the following quantities. Now that rule that's being referred to there is referenced on page 399 in your textbook. So you may want to turn to that to get a little bit more information. But I took these couple of screenshots here just so that we can quickly look at what that rule says. In general, what it says is based from the mean, one standard deviation out from the mean, that's both below and above, 68% of the values fall in that region. So in that darker green region, 68% of the values fall here. But if we go 2 standard deviations out from the mean, so if you see here this little bit longer line, 2 standard deviations out, 95% of the values fall within this region, under the curve. So this is this like medium green, darker green region together is 95%. And then the last part of the rule says if we go 3 standard deviations out, notice that we're basically at the very tail ends now of this distribution, we have here 99.7% of the values under the curve. So most of the values, almost 100%, are represented 3 standard deviations out from the mean. And that's again summed up down here at the bottom. I personally like the distribution, the diagram, and that's what I'm going to use to help solve this particular problem. So I'd want to start by first drawing a normal curve with the given mean and standard deviation. Now to do that, I just draw a horizontal looking line and a bell curve shape. And I know already that the normal curve, where its peak lies, is the mean. So I'm going to label this value here as 80. And I also know that I contain most of the data, 99.7%, within 3 standard deviations. So I just kind of eyeball here 3 tick marks to the right and 3 tick marks to the left. It doesn't have to be perfect, but again, I'm just trying to mimic the image that I see here on page 399. Now the numbers that I put on these tick marks are going to be distance from the mean by 15. So these values between tick marks from here to here, for instance, is 15. That's that standard deviation. So 15 units above above 80 is 95. And 15 units below, in the other direction, below 80 is 65. And I can keep doing that, adding and subtracting 15 to add on 15 in this direction and to subtract 15 in this other direction. Now I used a piece of software just to get a cleaner copy of the same thing. So I'm going to move that over here. So now I'll reference this shape. Okay, notice it's the same thing I was setting up here, just a little bit cleaner copy for purpose of the video. Okay, so one of the first questions was, let me go back. The first question was the percentage of scores less than 80. So 80 falls here on this normal curve. And I'm looking for what percent of test scores fall less than 80. So in other words, this region. Well, this isn't explicitly stated in the 68, 95, 99.7 rule, but it's more so stated back when we first looked at that definition of normal curve, that it contains symmetry about the mean. In other words, half of what we see on one side or is expressed on one side, and the other half is expressed on the other side of the mean. This is that line of symmetry. Half is on the left and half is on the right. Now we are asked to write these as percentages, so we would want to say 50%, as you see here, as you see written right here, 50% is less than 80. Again, I didn't explicitly use that particular rule. It's actually going back and using the definition of a normal curve. All right, and up next, we're asked the percent of scores greater than 95. So you can see why I like this visual here. It gives me a chance to actually see where 95 falls on that curve. And I'm looking for the percent greater than 95. In other words, to the right of that particular value. Just by eyeballing it, I see that it's less than 50%. And you might could even make a decent estimate, maybe say around 20-ish% if you had to eyeball the area of this region compared to the area under the entire curve, compared to all of this, in other words. Okay, so what we're going to do, though, is get a little bit more precise with that 68, 95, 99.7 rule. So the first thing I need to see is how far, or what is this 95 in relation to number of standard deviations from the mean? So I see that here's the 95, and it is one standard deviation, one SD, from the mean. So with that, I'm going to look for what value pairs with one standard deviation of the mean, and that is this 68%. So 68% of the values, this is, again, going back to the rule, it says 68% of the values fall right here, between one standard deviation of the mean. So that's one standard deviation below and one standard deviation above. This is 68%. But let's go back and use some symmetry and the fact that we know that 100% of the data is under the entire curve. So if 68% is here in blue, then I'm going to draw here this also in pink to the left. Then 100% minus 68% would be what I see right now represented in pink. So that is 34% is in pink. But that's both below one standard deviation, below 65 rather, and above 95. But these two things are also symmetric. So half of that value, half of the 34 is here, and half of the 34 is here. So if I just want one of these, and I'll draw it a little bit darker now, this is what we want here, just this region. I want to find half of 34. So divide that by 2 or take half, and that's how we get 16%, as you see there in that answer for part B. The most complex of these questions is this last one. And the reason why I would say it's a little bit more complex is it's because it uses two different standard deviations. It's using 50, which is, notice, 2 standard deviations below the mean, and it uses 95, which is 1 standard deviation above the mean. So here I'm actually going to use both the one I had circled earlier, that 68%. I'm going to use that value. And I'm going to use this value, that about 95% of the values fall within 2 standard deviations of the mean. So I'm going to need both of those facts. And again, just the fact that this entire figure is symmetric. Okay, so there's a few different ways we could go about this. So what I'm getting ready to show you is not the only way, but you can use any form of that symmetry and geometry there to help you solve this, along with the 68 and the 95%. So let's look at it like this. Remember earlier the work that we did to find the percent of scores greater than 95%? If I didn't already know that, I would need to do that work. So I'm going to find, in other words, part of the region I don't want. I want the region here that's between 50 and 95, but I already know that this piece is 16%. So let's do something similar to find this piece below 2 standard deviations away from the mean. So what we did there was we took 100%, because we know all of the data, everything under this curve is 100% of those values. We subtracted 95%, or we will subtract 95%, I'm sorry, because this is now 2 standard deviations out. In other words, we're thinking, we're kind of eyeballing here from here to here. Between those 2 tick marks is 95. If I subtract, I get the regions that are left, and I only need half of that. So half of 5% is 2.5%. So let me go back and see if I can erase just that green there. Okay, so that's what I need at this point. And I'm going to keep that information. So I've got that 16% is above 95. I have 2.5% is below 50. And now I need everything that is left. And everything that is left is between these two. And I know that all together, these 3 regions should sum up to be 100%. So let's take 100%, subtract 16, and subtract 2.5, and that's how we come up with 81.5% of the data, or the values, falls here in the blue region, as we see right here.